Every Zener diode has a voltage where it stops blocking current and starts conducting in reverse. That's its breakdown voltage. But pull one from an unlabeled bag, and how do you actually check that number? This circuit does it using nothing more than a small 3.7 volt battery. Here's the schematic. Let's walk through exactly how it works. The challenge is simple. Most Zener diodes are rated well above 3.7 volts. Some need 15 volts to break down, some need 30, some need over 50.
A single lithium cell can't reverse bias any of those on its own. So before this circuit can test anything, it first has to solve a smaller problem, turning a low battery voltage into a much higher one. That job falls to a timer IC, a switching transistor, and an inductor working together as a small boost converter. The timer IC free runs on its own, producing a continuous square wave without needing any outside trigger. That square wave switches the transistor on and off many times a second.
Each time the transistor turns on, current builds up through the inductor, storing energy in its magnetic field. Each time the transistor turns off, that field collapses, and the sudden release pushes a voltage spike higher than the battery itself. A small signal diode catches that spike and funnels it into a storage capacitor. And with every switching cycle, the capacitor climbs a little higher. Cycle after cycle, this pushes the voltage up to 60 volts, 16 times higher than where it started, all from one small battery and a handful of parts. A resistor across that capacitor keeps a light, constant drain on the boosted voltage, so it settles at a steady 60 volts even when nothing else is connected. That steady high voltage is now ready to test whatever Zener diode gets connected to the circuit. The Zener under test gets wired in with its cathode facing the boosted supply and its anode grounded, the same direction it would face in reverse bias inside a real circuit. A current-limiting resistor sits between the boosted rail and the diode, protecting it from pulling too much current once it starts conducting. Here's where the test actually happens. If the diode's breakdown voltage is lower than the 60 volts available, it clamps down and holds the voltage at exactly its rated point. Everything above that gets dropped across the limiting resistor instead. If a Zener is not connected, or its rating is higher than 60 volts, there's nothing to clamp the voltage, and it simply sits near the full boosted level instead. The last piece is showing that number to whoever's holding the probes instead. A small digital display module reads the voltage right at the diode's cathode and shows it directly as a number, updating in real time as different diodes are swapped in. There's no calculation needed and no reference chart to check. Connect a Zener diode, and its breakdown voltage appears instantly on the display. Put it all together, and this is a self-contained diode tester that needs nothing more than a small battery. A timer generates a switching signal. That signal drives a boost converter up to 60 volts. A test diode clamps that voltage to its own rated breakdown point, and a display reads the result directly. It's a compact way to verify Zener diodes without a bench power supply or a multimeter doing the math for you. If you build this circuit yourself, you now have a way to check any Zener diode's breakdown voltage without a bench supply or a multimeter. Just a battery, a handful of parts, and a display that tells you the answer directly. Thanks for watching, and I'll see you in the next one.